everyone, I am Prachi Desai from BE Computer, and today I will demonstrate and explain my mini project. So I have basically created a diabetes prediction system which will take input from the user and tells if the patient has diabetes or not. For that reason, I will be using one of the important machine learning algorithm, support vector machine. So motivation for doing this project is, as we know, diabetes is an increasingly growing health issue due to our inactive lifestyle. If it is detected in time, then through proper medical treatment, adverse effects can be prevented. So to help in early detection, technology can be used very reliably and efficiently. So using machine learning, I have built a predictive model that can predict whether the patient is diabetic positive or not. For that purpose, I will be using support vector machine. So let's first understand what support vector machine. So this is one of the important algorithm of supervised learning algorithm. In supervised learning, what we have done, we feed the data to our machine learning model, and our machine learning model learns from the data and its respective label. So here labels are most important thing. So what happens in this case, when we train our model with several medical information such as blood glucose level, insulin level of patient, along with whether the person has diabetes or not. So this acts as a label for this support vector machine. So once we feed this data to our SVM model, what happens is it tries to plot the data in graph, and once it plots the data, it tries to find the hyperplane. So in this image you can see the hyperplane. So what happens here, this hyperplane separates these two data. So once we feed new data to this model, so it tries to put that particular data in either of these group, either in positive hyperplane or in negative hyperplane, and by that it can predict whether the person will be diabetic or non-diabetic. So in this case we use several medical information for that purpose. Next, so this is the workflow. So first of all we need this diabetics data. So we will try to train our model with the data and respective label. Before feeding these to our model, there are lot of steps in between. We need to pre-process the data where we will try to analyze the data, and as this data won't be very suitable to feed to machine learning model, so we need to standardize this data because there are lot of attributes here, so a lot of medical information, and we want all these data to be in same bridge. So what we will do is we try to standardize all these data so that all these data lies in the same range. All these things will be done in pre-processing steps. So once we pre-process data, we will split the data into training and testing the data. So we train our machine learning model with training the data, and then we try to find out the accuracy score of our model with the help of these test data. So what accuracy scores tells? So it tells us how well our model is performing. So once we split the data into training and testing data, we will feed this data to our SVM, support vector machine classifier model. We will be using a classifier model where this model will classify whether the patient has diabetes or not. So once we have trained it, we have trained our SVMC model. When we give new data, it can now predict. So when user enter any new data, so it will predict whether the person is diabetic positive or not diabetic. So this is the overall workflow. So now let's first see the demonstration. So this is home page where you will have to enter the various values like glucose level of the patient, insulin level of the patient, BMI and age of the patient. So on clicking on this predict button, it will shows this message that you have diabetes, please consult a doctor. Let's move towards the dataset. So this is the dataset that I have used in this project. So this dataset consists of 768 samples and has total 9 attributes like pregnancy, glucose, blood pressure, skin thickness, insulin level, BMI, age of the person. So from these, out of these, eight are independent variable and one is dependent variable, that is target variable. So this outcome is a target variable which determines whether the patient is having diabetes or not. So here 1 represents the patient is diabetes positive and 0 represent it's diabetes negative. So now let's move towards the coding part. So I have developed this project in 6 steps which follows data gathering to model deployment. So step 0, import libraries and dataset. So all the standard libraries like NumPys, Pandas, Matplotlib and Seaborn are imported in these steps. I have used NumPy for linear algebra operation, Pandas for data frames, Matplotlib and Seaborn for plotting graphs. Then here the data set is imported using the pandas command read.csv. Next step, descriptive statistics. So here I have written the first 5 rows from the data set using this dataset.head command. Then using this dataset.shape command, I have concluded that there are 768 records and 9 features in my dataset. Next, from here, so this is nothing but the data information. Then here I have described the data set. So here some features like glucose, blood pressure, insulin, BMI have 0 values which represents the missing values. Next, then I have found the null values using null function. So there are null values for feature pregnancy, glucose, blood pressure. Next step, data visualization. So I have plotted the count plot graph. So it tells us that the data set is imbalanced as the number of patients who don't have the diabetes is more than the patients that have the diabetes. Next, here I have plotted the histogram for each feature. So this shows the distribution of data set of different attribute which we have used in our data set. Next, I have plotted the pair plot as well for each feature present in the data set. So here I have plotted the heat map using the function heat map. So from this correlation heat map, we can see that there is high correlation between the outcome and glucose, BMI, age and insulin feature. So we can select these 4 features to accept the input from the user and predict the outcome. Next step, data pre-processing. So in this data set, missing values are represented by the 0 value that need to be replaced. So these 0 values are replaced by NaN, not a number, so that missing values can easily be imputed using these. So these missing values are imputed using this fill and a command. Next, feature scaling and min max scaler. So here I have performed the feature scaling on dataset using this min max scaler function, so that it scales the entire dataset such that it lies between the 0 and 1. So it is an important pre-processing steps. Next, so from heat map we have seen that there is highest correlation value between the outcome and glucose, insulin, age, and BMI feature. So here we select these. So here we select the BMI, insulin, glucose, and age feature as X and the outcome as Y value. Next, here I have done the training and testing part. So the data set is split using this train test split command with an 80:20 ratio. That means the 80% of data set is used for training purpose and 20% of data set is used for testing purpose. Now the next step, data modeling. So here I have used the support vector classifier algorithm. As I have mentioned earlier, this support vector classifier is a type of supervised classification model whose objective is to classify the data based on the maximal margin hyperplane built using these super vectors. So this SVC has three main parameters. The first one is the kernel parameter, which signifies the type of the kernel, which can be linear for linearly separable data, and RBF or poly for linearly separable data. Then the second one is the gamma parameter, which is kernel coefficient. As the value of gamma increases, it tries to exactly fit the data set, which gives the generalization error and causes overfitting. Next, the capital C parameter. So it is nothing but the cost of misclassification of model. So the high value of the C parameter gives us the low base or high variance. So next step, model evaluation. So here I have imported the accuracy score from sklearn metric library for calculating the accuracy of the system. So I have chosen three metrics: accuracy score, confusion metrics, and classification report for evaluating the model. Yeah. Now we'll move to .py file for web application. Here I have imported these packages, these Flask, request, JS, Onify. This render template is used so that it will use the files that I have stored in this template folder. These .html files and CSS file. For that purpose, I have used this render template library package. So using this render template, we can access the .html and .css file. Then next, app equals to Flask name. So here I initialize the app. Then for the then here def home, it will return the render template index.html. So this is for the home page, this is path for the home page, and so this part will give us the home page. Next, so now this method will support the post only. So I have created one method predict for rendering the result on HTML GUI. So user will enter the data here, and user will enter the data, and here I scale down the data and put all the data into the array. Now I so if the prediction is equals to 1, then it will print the message that you have diabetes. Please consult a doctor. Otherwise, it will display the message you don't have the diabetes. Then after this if name equals to main. So here I have called the main application using this command. So this is how this project works. Thank you.